Hello guys, this is going to be the proof for the sum of an arithmetic series. So, an arithmetic series is basically any series that just has a common difference. So, 1, 2, 3, 4, 5, and 6 all have a difference of 1. So this is an example of an arithmetic series. You've also got 2, 5, 8, 11. As you can see here, the common difference is 3. So, something that I like to start off with is, say we have the first 100 terms. So 1 plus 2 plus 3 plus 4. On and on until you get to 98, 99, 100. Instead of using your calculator and just typing in these, is there a quicker way to do it? Well, what you could do is you could write out the sum again, but you can write it the other way around. So instead of going from 1 to 100, you can go from 100 to 1. And we should get 3 plus 2 plus 1. And then if you look at these terms here, so if we add both of these, you can see 100 plus 1 gives you 101. So if we add both of these, we get on this side, well, 2 lots of the sum of the first 100 terms. And then we get 101. Well, the next one also gives us 101. The next one also gives us 101. And let's say we keep on going, check at the end, 101, 99 plus 2, 101, 100 plus 1, 101. So, now we've got an expression for the sum of 100, and we've got a bunch of 101s. And to find out how many we have to look at the number of terms. Well, we're going from 1 to 100, and that's how many 101s we have. So, we have 100 101s. So that's the sum of 2 lots. That's 2 lots of the sum to 100. So how do we just find 1? Well, if 2 lots of the sum to 100, I'll just write this easier. So this is just going to be 10,100. Well, the sum to 100 would then be 10,100 over 2, which gives you 5,050. Okay, well, let's generalize this now. Let's say we have an arithmetic series, and we basically, first term is A. A could be 1 or 2 or 3 or 4 or anything. And we know that we always have a common difference of D. So the next term would be A plus D. The term after that, A plus 2D. After that would be A plus 3D, and on and on and on. So let's try to generalize this and find the sum for the first n number of terms. So that would be A plus D, that's the second term, plus A plus 2D, and I go on and on and on, and we get to A plus n minus 2D plus A plus n minus 1D. So let's look at what we did here. Well, for the sum to 100, we wrote it out, and then we wrote it out backwards, so we could add them. So let's do the same thing here. So it's equal to A plus n minus 1D plus A plus n minus 2D plus A plus n minus 3D, and on until you get A plus D and just A. So now let's look at what we did here. So we added them both together to get 101, 101, 101. Let's see if the same thing holds here. Okay, so if we add these two, we get 2Sn, and that would be, well, what's A plus n minus 1D? Well, A plus A gives you 2A, and you'd have plus n minus 1D. Let's look at the next term. You have A plus A, which is going to be 2A, and your next thing is going to be, well, you have D plus n minus 2D. Well, if you look at D plus n minus 2D, that is basically, you can factor out D and write that as 1 plus n minus 2. Does that make sense? Because if we factor out D, to get D, you times it by 1, and to get n minus 2D, you times by n minus 2, and that just becomes D lots of n minus 1. So it became n minus 1D. And this next time you'd have 2d plus n minus 3d, and each time you just carry on getting n 2a plus n minus 1d. So it keep on going, and your final term would all have 2a plus n minus 1d. So we know a sum, and now we can look at how many we have. So we know that there's n number of terms, so we must have n lots of 2a plus n minus 1 d's. And then if we just want Sn on itself, we just divide by 2. So Sn is equal to n over 2, 2a plus n minus 1d. And that's it. That's basically the formula. You should get it in most of your formula booklets. Okay. So now let's apply it to what we started off with. So we wanted the sum from 1 to 100. So let's see what that is. So we had 1 plus 2 plus 3 plus 4, on. And we found that the difference was 1 each time. So d equals 1, and your first term was 1. So a is equal to 1, and you went all the way to 100. So n is equal to 100. So now let's use the formula we found up here. So S100 is equal to n is 100, so 100 over 2, and if we look here, our a is 1, so it would be 2 times 1, and you'd have n minus 1d. Your n is 100, so it'd be 100 minus 1, and d is just 1. So now, tidying this up, you have 100 over 2 is 50, you have 2 plus 99, which gives you 50 lots of 101, and that is just 5,050. Thank you for listening, and bye-bye.